Okay, now that we've covered simplifying radicals and adding and subtracting radicals, we will move on to multiplying and dividing radicals. So in multiplication, unlike addition and subtraction, you can multiply unlike radicals. So in example 1, I have 5 radical 2 times 4 radical 5. Since they are unlike radicals, that's okay. When we multiply, you multiply the numbers out front, sometimes called the coefficients, with each other, and then you multiply the numbers under the radicals with each other. And that gives us 20 radical 10. We would then check to see if we can simplify 20 radical 10, and in this case we cannot. In example 2, we have radical 20 times 3 radical 3. There are two different ways to kind of think about this. One method would be just to multiply. The coefficient in front of radical 20 is a 1. And so if we were just to multiply, we would get 3, because that's the 1 times the 3, and then we would get radical 60. Now what we would have to do is break down radical 60 like we did in the previous video into two numbers that multiply together where one of them is a perfect square, 4 and 15. The 4 comes out as a 2, we get 2 radical 15, and then don't forget about the 3 that we had earlier, and that would give us 6 radical 15. Method 2 would say to simplify first. So one might take radical 20 and first simplify it. If you did that, it would be 4 times 5, because the perfect square inside of 20 is 4. This comes out as 2, and so we have 2 radical 5 times 3 radical 3, and that gives us 6 radical 15. You see, we get the same answers. One of them we're just simplifying first, where the other one we're simplifying last. Alright, now that you see all the two previous examples on the previous slide, pause the video and try these two. When you're done, unpause it, and I'll work them out. Now that you've tried them, you can see that the one on the left was radical 2 times radical 6, so I simply multiplied radical 2 times radical 6. 2 times 6 is 12. I ended up getting radical 12. Radical 12 has a perfect square of 4 in it, and so it's 4 times 3, and the 4 comes out and becomes 2 radical 3. The one on the right, I chose to simplify the radical 12 first. So you see I broke down radical 12 to 4 times 3. The 4 came out as a 2, so radical 12 became 2 radical 3. Multiplied it by 4 radical 6, which gave me 8 radical 18. The disadvantage of doing it this way is that you might then have to break down your radical again. Radical 18 has a perfect square in it. It is 9 times 2. That 9 turns into the 3, and the 3 multiplies the 8 and becomes 24. If I go ahead and do it the other method would say just go ahead and multiply right away. So 4 times 1 is 4, and 6 times 12 is 72. Now I just have to worry about breaking down one number instead of breaking down a number and then doing it again. The disadvantage of doing it this way is you can see that my numbers are a little bit bigger. I have to think of the perfect square that's inside of 72. It is 36. This becomes 6 radical 2 with the 4 on the outside still gives me 24 radical 2. Or like you saw in Mr. Reese's video earlier, if you didn't figure out the biggest perfect square of 72 was 36, you might break it down to 9 and 8, and then you would have to break down 8 again. So there is still a way to get to that end result. We can also multiply radicals with a binomial, or two radicals, or something in parentheses, and simply use the distributive property. Would say that radical 2 times radical 3, we would multiply the numbers under the radical, becomes radical 6, and then radical 2 times radical 3, remember there's a 1 outside this one, so the 1 multiplies the 3, and becomes 3 radical 2. Again, we would stop and double check to make sure that we don't have any radicals that need to reduce or break down, and we do not. Okay? In example 2, we will see that happen. If I multiply the 3 radical 5 by 2, the 3 and the 2 multiply, which gives me 6. The radical 5 multiplies with no radical there, just stays radical 5. If I multiply the 3 radical 5 by the radical 10, the 3 multiplies with the 1, and the 5 and the 10 multiply and give me radical 50. Once again, I have to now stop and say, can I break any of these down? And of course, I can break down right there radical 50. It does have a perfect square in it, and so I would call that 25 times 2, and that breaks down to 5 radical 2. The 25 comes out and becomes 5. Don't forget we had this 3 sitting out front, and so that would multiply, and that little piece gives me 15 radical 2. We did still have this beginning here, this first term, 6 radical 5, and so that 6 radical 5 is the first part of the term. Now remember from your video, your earlier video, that we would then see if we can add these, and this is where things get a little confusing, because even though we were multiplying, and you can multiply unlike radicals, you cannot add unlike radicals. And since this is radical 15 and this is radical 2, we cannot add them, and this would be our final answer. Lastly, with multiplication, we could go ahead and do FOIL, or multiply a binomial times a binomial. Just like we would FOIL anything, we would do first times first, so negative 3 times 2 gives us 6. We would do outside, negative 3 times minus radical 5 gives me plus 3 radical 5. Notice it's not radical 15 because the 3 is outside a radical and the 5 is inside the radical. We would do the inside numbers, and that would be radical 5 times minus 2, which gives me minus 2 radical 5. Again, the number outside cannot multiply a number inside. And then we would do this last one, which becomes radical 5 times radical 5, which becomes minus radical 25. Okay, we should have 4 terms here, and then we go through and we try and see if we can simplify and or combine anything. First thing I notice is both of these are radical 5s, so I know that I can put these two together, and I would do that by adding or subtracting their coefficients. In this case, it's a plus 3 and a minus 2, so that leaves me a 1 radical 5. The other thing I notice is that I have a perfect square here, and the square root of 25 is 5. So this little term right here becomes minus 5, which now all of a sudden could be put together with this 6 in the front. And 6 minus 5 is 1. So I end up with 1 plus 1 radical 5, or 1 plus radical 5. Again, you cannot add those two together because they are unlike terms. Now that you saw me do a couple examples of distributing into a binomial and multiplying a binomial by a binomial, pause the video and try these two problems below. So you should have gotten these answers. The first answer would be 2 radical 15 minus 3 radical 10. Notice they are not like radicals, so I did not take this any further and combine them. The last one should be negative 17 plus 7 radical 5. In the first one, I distributed the radical 15 to the 2, and that gave me 2 radical 15. I distributed the radical 15 to the 6, and that gave me radical 90. 90 is 9 times 10, 9 being my perfect square, and comes out as a 3, and that is where I ended up with the 3 radical 10. In the second one, I went ahead and FOILed. Radical 5 times minus 3 radical 5 became minus radical 3, became minus 3 radical 25. Radical 5 times 1 became radical 5. Negative 2 times negative 3 radical 5 became positive 6 radical 5. And negative 2 times 1 became negative 2. Square root of 25 is a perfect square, so I turned it into 5, and then multiplied by the number out front gave me negative 15. I added these two, which were like radicals. This was a 1 radical 5, and this was a 6 radical 5, and that's where I got 7 radical 5. And then I brought the negative 2 down and combined it with the minus 15 to give me minus 17 plus 7 radical 5. Lastly, we will discuss dividing radicals. When you divide radicals, you try to get the radical out of the denominator, or the bottom of the fraction. This is known as rationalizing the denominator. There's a couple different ways to do this. The first way is to decide if you have any perfect squares in the denominator. So for example, in example 1, you notice that square root of 60 is a perfect square. The square root of 60 turns into 8, and I already have a 5 at the bottom, and so I know my denominator is going to be 40 without having to do any work. The numerator is the square root of 20 with the 4 out front. I do know that 20 has a perfect square in it. It is 4 times 5, and that becomes 2 radical 5. So this numerator is 4 times 2 radical 5 after I've simplified the radical 20. The 4 and the 2 multiply together, and I get 8 radical 5. Now, like with all fractions, we would go ahead and reduce if we can, and if we look at this numerator and denominator, we do have an 8 and a 40 right there, and that 8 and 40 can both reduce, and I would divide this by 8, and I would divide this by 8, and that would give me 1 radical 5, or just radical 5, over 5. Notice, you cannot divide this 5 that's inside the radical with this 5 because it is outside the radical. These are two different numbers. In the second example, I have 2 radical 6 over radical 10, and what I do notice is that I can do one of two things. I can either go ahead and try and get the radical out of the bottom by multiplying by something that would be a perfect square. In that case, it would be radical 10, because I know that radical 10 times radical 10 is radical 100, and the square root of 100 is 10. As long as I multiply the numerator by the exact same thing, I have not changed the value of this fraction. So the numerator would become 2 radical 60. Now I have moved the radical out of the denominator, but I have now a number that has a perfect square inside the radical, which is 60, and so I need to now simplify that. So I think of two numbers that multiply to give me 60, one of them being a perfect square, and that is 4 times 15. The 4 will come out as a 2, and so I will have the original 2 times 2 radical 15, which is my simplification of 60, and I will have 2 times 2, 4 radical 15 over 10. Once again, like in our previous example, I can go ahead and I can reduce 4 and 10, and that will go ahead and give me 2 radical 15 over 5. I, again, cannot reduce the 5 that's in the radical, 2 radical 15 over 5. I cannot reduce the 15 that's in the radical with the 5 that's in the denominator, because one is in a radical and one is not in a radical. Now I've deleted our first example so that I can just redo this second example a little bit different way for you. And so if that's 2 radical 6 over radical 10, some people, because both the radical 6 and the radical 10 are in a radical, we can reduce that fraction. And so that becomes 2 radical 3 over radical 5. What we've just done is we've just basically divided each one of those by 2 and made the radical that's inside, or the numbers that are inside these two radicals, smaller. Again, we can do that because they're both in radicals. We cannot reduce these because one's in a radical and one's not. Now what's the advantage of doing that? You can see our numbers are smaller, and now the only number I need to get rid of on the bottom is radical 5, and so when I multiply the top and bottom by radical 5, I end up with 2 radical 15 over, this is radical 25, which is 5. So I get the same answer, and what I've done is I've done my reducing at the beginning of the problem by reducing the fraction right here, instead of having this larger number 60, having to break 60 down, having to multiply that, and then having to reduce towards the end. So if we look at our final example, 2 radical 5 over radical 2. I could not do it the second way I did it on the previous slide because both 5 and 2 will not reduce. So the only way to do this is to multiply by something that will give me a perfect square on the bottom. The goal is to try and get a perfect square, and what you'll see as you do more of these is it typically results in multiplying by the same number. 2 times 2 is 4. We know the square root of 4 is 2, and that gives us a number on the bottom that does not have a radical. Now the numerator can be multiplied even though they are unlike radicals, and I get 2 radical 10 over 2. Once again, I can reduce anything that's outside the radical with something that's outside, or I can reduce inside with inside. These 2's will cancel, and I will get radical 10. Pause the video and try these three problems. The first one is pretty simple because the denominator is a perfect square. The second one you could do one of two ways. The third one, you really just have to figure out how to get that radical out of the bottom. When you're done, unpause it and we'll go through the answers. So you should have tried these. Notice in the first one, the answer is 2 radical 2 over 5. What I did is I just simplified the bottom, which was the square root of 25, and that turned into 5. The numerator is square root of 8, which is 4 times 2, and that gave me 2 radical 2. Excuse me. The second one, I chose to reduce the fraction first, so I reduced the 10 and the 6 by dividing by 2. That gave me radical 5 and radical 3. Now I only need to rationalize the radical 3 by multiplying by radical 3, and I got 5 radical 15 over 3. If I would have gone ahead and multiplied by the radical 6, I would have had radical 6 on top, which would have given me a 60, a larger number to break down, but it could have been done. And the last one, because nothing could have been reduced, I went ahead and just multiplied by radical 5 over radical 5, and so that gave me the square root of 25 on the bottom, which turns into 5, and the numerator became 5 root 30, and 30 does not have a perfect square. Hopefully, these examples helped you a little bit. When you come in tomorrow, we will be able to talk about if you're struggling, if you're not struggling, if you need a little bit more practice.